Okay, so they're asking us to find the least common multiple of 4b squared and 7b cubed. Well, if I was just asked for the least common multiple of 4 and 7, right? Talking about multiples, we're saying counting by fours. 24, 28. Looking for a common multiple just means that we are looking for, the same multiple on each list. And usually a good way to find those is just to multiply the two numbers. If we do 4 times 7, we're going to get to 28. So if it's 4b squared times 7b cubed, we're not multiplying this. We're just finding a common multiple. If we want a common multiple of those, well, multiples of 4b squared is just going to be 4b squared, 8b. What am I thinking here? Is that right? 8b squared. Well, this is okay. So this is if I'm multiplying by if I'm just doing, what is this number times 2 times 3 times 4. If I do it like this, then I am never going to get to a common multiple with this number, right? Because I'm just going to end up with b squareds up here. So instead of multiplying by 2 and by 3, what I should instead do is I should multiply by 2b or 3b. That will make my multiples a higher order on the b value. And then eventually, if I go down my list, I should hit 28b cubed when I multiply by 7b. Now with the 7b cubed, I don't need to multiply by an order of b because I'm already at that third order. So for that one, I would only have to multiply by 4 to get there. Okay, so this is just slightly complicating things by adding these variables at the end, but you just have to kind of keep track of how much more b do I want to get to a common multiple of the other one. So I think my least common multiple is going to be 28b. Let's see if that works out right. Okay. Here, find the least common denominator. So typically, like I said, if you have 3/4, 4/5, what you'll typically do to find a common denominator, is you'll do something like this. You'll say, I want to get them both to be 20ths. I'm going to multiply the left one by 5/5. I'm going to multiply the right one by 4/4. And that'll give this one 20ths. That'll give that one 20ths. And then I can just add together whatever I get on top. So we're going to do the same kind of program. Here we have 7x and x minus 7. Well, what we need to do to give them a common denominator is we would need to multiply the left one. So they haven't asked us to add or subtract, but this is kind of like the gist of what they're going to want us to do later. So I'm just going to kind of describe it that way. We'd multiply the one on the left by x minus 1 over x minus 1. And we multiply what is on the right by x minus 7 times x minus 7. Sorry, x minus 7 over x minus 7. Okay, misspoke there. Okay, so that is what we would do in order to get a common denominator. Therefore, what is the common denominator? Well, it's going to be x squared. What will we have? Foiling here. So we'll have x squared, we'll have negative 7x, another negative 1x, and we'll have positive 7. So our least common denominator, I don't know if they want this in factored form or not, but I'm going to write it as x squared minus 8x plus 7. And I'm going to try another real quick. I want to see if they would have accepted it the other way. If I just put x plus 7. x minus 7. Okay, so it accepted either way. And then in that case, we could have written that as this is x plus 7, x minus 7. That would have been x squared minus 49. So I think they're going to take it in whatever way that you want to put it in. Okay, so here we're actually going to do this. So 6x and 8x. To get to the common multiple here, we've got 2x plus 5 over 6x. I've got x minus 6 times 8x. So to find a common multiple, in this case, I'm not going to multiply the right side by 6x over 6x, because that's just going to make the order here higher than it really needs to be. I'm just going to do 6 over 6. Here I'm going to do 8 over 8. Okay, so on the left side, I'm going to get that look right? Yeah, I think so. I am going to get 16x plus 40 over 48x. And on the right side, I'm going to get 6x minus 36 over 48x. And then at this stage, I can actually put those two fractions together. So 16x minus 6 would be 10x. 40 minus negative 36 would be 76. And then I would have 48x on the bottom. At this stage, we just want to probably reduce this fraction down where we can. So usually I don't try to jump ahead too fast. If I see even numbers, I'll just pull out a 2 and see where we can go from there. So 76, that would be like 35 and 3, so I think 38. And down here, we would have 2 times 24x. Don't see what I'm going to pull out of these two numbers to get any further along. So I think my final answer should be 5x plus 38 over 24x. Okay. Okay, on this one, we need this denominator to go up by an order of u. But we also need to find a common multiple. So I'm going to say 9u over 9u. They may have a smaller common multiple, but I'm just going to do 9 and 9 and call it good. So over here, we'd be doing 12 over 12. Well, there's probably a faster way to do that. What about 36? What if we got to 36? So if I did 4 over 4 and 3u over 3u, I think that'll give us some smaller numbers to work with. So 9 and 4 make 36, and 3 and 12 make 36. So that should work out. Okay, so we'll have 15u over 36u squared minus 16 over 36u squared. So in total, we will have 15u minus 16 over 36u squared. I don't think we're going to find common things to factor out on the top. So let's just try that one out. 15u minus 16. Now I could have just done the thing where I just multiplied, by each other's denominators. Just would have given us bigger numbers that we would have had to simplify to this one in the end. So it's as it is. Okay, so on this one, what do we have? We need to increase the order of the c's on the left by 1. All right, we have c to the first power, but we need it to be c to the second power. So we're going to have a c that we're going to multiply. On the right side, we don't have any d's, so we're going to need to go d cubed over d cubed in order to get these d cubes to match on the denominators. We've got a b over here that is not over here yet, so let's put that one in. And then finally, this one's 6, and if we want them both to be 6, let's just multiply this one on the left by 2. Okay, so you're just kind of looking for what is on the bottom on one side, what is on the bottom on the other, what do we need? So over here, we can get 4bcw over 6bc squared d cubed minus 5d, looks like to the fourth, I think I have 3 of them, and then another one, d to the fourth u cubed over 6b c squared d cubed. Okay, quite a lot of letters in there. So altogether we'll have 4bcw minus 5d to the fourth u to the third all over that 6bc squared d cubed. Okay, now I'm looking up here. I don't see any common variables. So B, C, and W, D, and U. So there's no common variable I can pull out and hope to cancel out on the bottom. 4 and 5, there's not going to be a common factor to pull out of there. So I think this big mess of an answer is going to be what I need to type in. So let's try that out. 4BCW minus 5 U to the third all over 6BC squared D. Oh, thank goodness. Okay, here, these two factors on the, or sorry, these two denominators, I don't see anything really obvious about like what common denominator we want to look for. So I'm just going to do the easy thing. I'm going to multiply the one on the right by the denominator on the left. And I'm going to multiply the one on the left by the denominator on the right. Okay, now I haven't made this clear, but and I'm sure it is clear to most, if not all of you, but I've got to do it on the top and the bottom because if I don't do that, I'm changing the expression. If I have it the same on the top and the bottom, then I'm just multiplying by 1, and nothing is changing about what the original expression said. So we have 8x squared. We've got 56x squared minus 72, and then we've got minus. Ooh, what am I going to get up here? I'm going to get 7x squared. I'm going to get negative 9x, 21x, and negative 27. All of that 6x squared minus 72. The 8x squared minus the 7x squared on the top will at least give me just x squared on the top. Then these two would come together and give me 12x, but I'm subtracting that. So I'm going to have minus 12x. And then I'm going to be subtracting negative 27, so I'm going to be adding 27. On the bottom, everything is going to be over 56x squared minus 72. Now, I don't know for sure that we can't cancel things out, so, well, it kind of looks like we're going to be able to. That's kind of my assumption. It seems like we're going to be able to cancel things out. So let's see what we can do. I'm going to type it in real quick first just to check if I like this or not. But I have a hunch these numbers all look pretty factorable. Here. Indeed. Okay, so what can we do? On the bottom, we could factor out a 2 just to get started. And we will have 28x squared minus 36, which means we could have factored out another 2 and had 4 times 14x squared minus 18. Or we could factor out another 2. Another 2 would give us 8 in the front. And we would have had 7x squared minus 9. Okay, so that's the most I can factor out of the bottom. Now, if you get that other stuff all the way over there, x squared, negative 12x, 27. I don't know how I would get this factor, so I'm not sure that's going to get me anywhere. But let's hold off for a minute. What does the top factor into? So we need 2 numbers to multiply to give me 27, which would be 9 and 3, but we need them to add up to negative 12. So x minus 9, x minus 3. So I wonder if something went wrong through my steps there, because the bottom of that fraction, there's nothing I can pull out of this right here. At least I don't think that there is. Yeah, so something appears to have gone kind of messy there. Let's see if I can look at this work again. So we have x over 7x minus 9. We're subtracting x plus 3 over 8x. And multiply 8x over 8x. That'll give me 8x squared. 8 and 7 is 56. X squared. 8 and 9 makes, 8x and 9. There we go. That was a problem. Should have been negative 72x. Should have been the same thing here. Which means I could have factored out at least 2x from all this stuff. And yet, I don't know that that helps anything. 8x times 7x is 56x squared. 8x times negative 9 is negative 72x. So that one should be 56x squared, negative 72x. Up here, let's just make sure this all works. 7x squared, negative 9x, 21x, and negative 27. Those two to come together to make 8x squared minus 7x squared was that one. These two, maybe that should have been a plus. Oh no, it shouldn't have been plus. 8x squared minus 7x squared is x squared. 8x squared minus positive, or sorry, we don't have anything over there in the first order x's. So we have minus, this is going to be positive 12, so we have negative 12x when we put them together, because we are subtracting. We have positive 27. That factors to x minus 9, x minus 3. Well, so that we don't waste too much time here, there's something in there that's going wrong. Let's just take a look at the explanation and see how that one went through. Don't want to spend too much time on any of these. Okay, so let's see how they do this one. They take our original amount and they multiply the left side by 8x over 8x. They multiply the right side by 7x minus 9 over 7x minus 9. So they get, I guess they never put that together on the bottom. They just keep it apart. And after they simplify this, so that all looks the same, that all looks the same. X squared minus 12x plus 27, that looks the same. X minus 3, 7 minus 9. Okay, so I guess maybe they would have just accepted it if I had thrown that x back in that I noticed and kept everything else the same. Okay, so wasn't very far off. There was not stuff to cancel out and just came up with a big, nasty answer at the end where I was off by x on the denominator, 1 factor of x. Not too bad. Okay, moving on. We've got 5 over 3x minus 8. We're subtracting 6 over 8 minus 3x. Kind of curious here if there's any shorthand way to do this, because when I'm looking at these two denominators, they are opposite of one another. So whatever the value of this one is should be this one should have the inverse value. So for example, well, I'm just trying to think. Is there a really quick way to do this? I feel like there's probably a very quick way to approach this one. It's not immediately jumping out to me. Maybe I'll play around with this one later on my own time and see what we get. The tried and true way to do this is just going to be to say 8 minus 3x over here. (3x minus 8 over here). So what would we get? We get 24x. We get another 24x. We would get negative 9x squared. And 8 times negative 8, we'd get negative 64. Which actually, together. So let's just do 8 minus 3x times 3x minus 8. Let's keep them factored, which isn't a bad idea. Oftentimes keeping things factored, like I said before, having stuff factored lets you cancel stuff out pretty easy. So let's just simplify what we have on the top so we can put them all together. So we will have 40 minus 15x minus 18x and negative 48. 18x and negative 48. I think that looks good. Okay, all over what we had on the bottom there. So that will be 40 minus negative 48 should be 88. Negative 15x minus 18 should go down to negative 33x. And then over here, we'll just have that product of 8 minus 3x and 3x minus 8. On the top, it looks like I could pull out a factor of 11 to get 8 minus 3x. And that'll allow me to cancel out one of my factors on the bottom. Okay, that looks like a pretty clean way to go through that. So maybe the advice I should give you is to not multiply the denominators. Just keep them in factored form. Let's see if this one works. 11 x. Okay, it's interesting. 5 and 6 make 11, and then we just have the original part. I wonder. I think there's more intuitive ways to approach that, since we have the same difference with a different positive one or negative bottom. But we'll leave it alone for now, so we can just move on. This guy, yuck. Okay, let's see how this one works out. So I would think we would probably want to try to do some factoring on these things. So let me do this differently. Let me just write out each one and see how we can factor them. Each denominator and see how it can be factored. Okay, luckily none of them have coefficients in the front, so that kind of makes it a little easier. So just to kind of remind you of the process, we're looking for two numbers that will multiply to give negative 24, that'll add up to give 5. So they need to be 5 apart, with one of them being more positive than the other. So two numbers that multiply to give me 24 that are 5 apart. What might that be? We got 12 and 2. We got 4 and 6. We got negative 24, so one of the numbers needs to be negative. What else do we have? 8 and 3. That's probably going to be our go-to one. So we're going to want negative 3, positive 8. Okay, I think that should work. All right, these two give me negative 24. We'll have 8x, and we'll have negative 3x. Or sorry, those were supposed to be u's, weren't they? Okay, the next one, two numbers that multiply to make 40 that are 3 apart. So that should be, well, we'd have 10 and 4, we'd have 8 and 5, I think would do the trick. We want more positive ones overall, so we're going to have u plus 8, u minus 5. Over here, we're going to have u squared, negative 8u, 15. So two numbers that make 15 would be 5 and 3. If they're both negative, they'll multiply to make a positive number, and we'll get negative 8. So u minus 5, u minus 3. Okay, so now we can take those factored forms of those three fractions. I think I have them in the right order. Negative 24, negative 40, 15. Okay. And we can rewrite our expression as 2u over these guys plus 5 and then minus 2 plus 5 minus 2 not big enough. Okay, so this, once we've got them factored, this one doesn't get too hard. All we have to do is we are going to have, in the end, everything is going to be over u plus 8 times u minus 5 times u minus 3. Okay, so we're going to get each of these three fractions to have all three of these factors. So each of them have two of them, right? This one is just missing the u minus 5. This one's missing the u minus 3. This one is missing the u plus 8. So I would be, I'm not going to show this step. Hopefully you can kind of just follow along. But for this one, I'd be multiplying the top and the bottom by u minus 5. So I would have 2u times u minus 5. And then we'd be adding the next part, which would be 5 times, well, this one, I'd have to multiply, I'd have to get that u minus 3 in there. So we'd multiply u minus 3 on the top and bottom. And then for this one, we'll have that minus 2 times, well, we need to add the u plus 8. So we do u plus 8 over u plus 8. So it would show up on the top of that one. Okay, now we can just go through and simplify the top. So we're going to get 2u squared minus 10u plus 5u minus 15 minus 2u minus 16. Let's just work with that without looking at the denominator yet. So we'll have 2u squared minus 10 plus 5 minus 2, so minus 12, and plus 5 would be minus 7u. And then minus 15 minus 16 would be negative 31. Okay, so that guy is going to be over u plus 8, u minus 5, u minus 3. Okay, so I'm going to cross my fingers and hope that I cannot factor any of these three out of that one, which you'll be able to. I'm just hoping that I don't. So, although I don't know anything I can divide 31 by, so actually, chance that this is good. Ah, thank goodness. Two more of this one, and then we'll take another little break. I think we're going to max out our 2 hours today, but maybe not. We'll see. Okay, so for this one, we want to use that same idea. We're dividing by a fraction, so we're going to change that to multiplication. So we're going to say 6 over u minus 3 plus 1 over u plus 4. It's going to be multiplied by, and then, okay, so actually on this part, I want to be careful because I think I need to combine these first before I flip it. So let's keep the division sign for now. We'll flip it in a moment. So we're going to take this whole quantity over here, and we're going to divide it by this one. Okay, so over here we would have 6u plus 4 plus 1u minus 3 all over u plus 4 or u minus 3. Okay, right, I'm just multiplying this guy by u plus 4 over u plus 4, and I'm multiplying the right one by u minus 3 over u minus 3. That whole quantity will be divided by over here 9 times u plus 4 minus 2 times u minus 3. All over, same thing, u plus 4, u minus 3. Oh, this is going to be nice. Check this out. Okay, so since we're dividing, we're going to flip this fraction over, and then we're going to cancel out u plus 4, u minus 3. This one will be on the top now. So I would flip this, and this stuff here and here will cancel out. And my final fraction will just be 6 u plus 4 plus u minus 3 over 9 u plus 4 minus 2 u minus 3. Let's just put that in and see if they're happy with that. That might be as much simplifying as is going to occur on that one. You can always hope. Type this in. Let's try to simplify things. You can simplify it further. Gosh darn it. Okay. So what can we do? We can say we have u plus 4, u minus 3. I guess we're just going to have to go through. So 6u and 24, u and negative 3 over 9u, 36, negative 2u, positive 6. That's going to be 7u plus 21 over 7u plus 42, which will be 7 times u plus 3 over 7 times u plus 4. Or not plus 4, sorry, plus 6. 7 times 6 is 42. Okay, u plus 3 over u plus 6. Okay, that's not so bad, actually. All right, last one on this one. I'm sure it'll be the easiest one yet. Okay, let's see what we got. So 5 over v squared u, and then we're going to do that divided by the quantity 7 over u squared minus 1 over v. We're going to get that right side simplified. So that's going to be divided by the quantity 7v over v u squared minus u squared over vu squared. Okay, so I've multiplied the right side by u squared over u squared. I've multiplied the left side by v over v. That allows me to put those ones together. Let's just get this back. So 5v squared u divided by that guy. So that is going to be 5 over v squared u divided by 7v minus u squared. Nothing to simplify there. Over vu squared. Okay. Now we can flip it and turn it into multiplication. Oops. There is a u to cancel out with a u up here to cancel out. There's a v to get rid of and an order of v to get rid of there. So we should have 5u over 7v squared minus u squared v. I think that's what I'm going to try out. Excellent. Okay, so that was it for the Tuesday assignment. I will put that into the Canvas course as well, so that if you need to go through that. Looks like Lally at some point caught one of my